Although these days in DC, seems like people are mostly interested in stopping people from solving public policy problems. I also moonlight as a talking head on cable news talking about politics. And if any of you have been watching television this weekend, you know we just had the White House Correspondents' Dinner, which a lot of people call Nerd Prom. I didn't go this year because I was on my way out here to what feels a bit like Nerd Camp, if it was a really high-class Beverly Hills version of Nerd Camp. Today we're not going to talk about politics, which is dysfunctional. Instead, we're going to talk about 3D printing, which is highly functional. The professionals call it additive manufacturing. I will let our panelists tell you more about how the 3D printing process works. And in fact, we have a demonstration of the process, which you'll get a chance to see. And that will be fun for me to be in a room with people who talk about ideas and start a process and come up with a tangible result at the end. Never happens in my business in DC. But whether it's the ability to pick and choose which movies or TV shows you want to watch and when you want to watch them, which news stories you want to read and where you want to go to find them, or find your own hotel room and flights, modern technology is democratizing most of our lives. We make the choices that work for us, and that process has disrupted so many industries, from telecommunications to journalism, travel, you name it. Now we are on the cusp of democratizing manufacturing. Some say 3D printing is at the developmental stage of the dot matrix printer 25 years ago. And if this technology continues along this path, it will disrupt the way that we make products all over the world. Some say we are moving from mass production to mass customization. And I come at this from a couple different perspectives. First, I grew up in a family where we watched a lot of Star Trek. So I want to know how far we are from having our real life replicator, so I can get a tricorder or a cup of tea, Earl Grey hot. A couple of Trekkies in here too. Secondly, I want to talk about the implications of 3D printing. What does it mean for manufacturing? How will the average citizen or entrepreneur engage this technology? And because I come from a policy background, let's talk a little bit about the implications for IP protection, safety, quality control, and workforce. To walk us through this are two great panelists. Avi Reichental is president and CEO of 3D Systems. Under Avi's leadership, 3D Systems, a global provider of 3D content to print solutions, including personal, professional, and production 3D printers, integrated print materials, and on-demand custom parts services for professionals and consumers alike. Peter Weimershausen. Yep. There you go. Peter is the CEO for Shapeways, the online marketplace and community for personalized production where anyone can make, buy, and sell their own products. Shapeways.com is the world's leading 3D printing marketplace and community. Welcome to our two panelists. And Peter, I'll let you get started, and we will hear from Avi, and at the end we'll have some Q&A and get a chance to hear from you a little bit.
All right, sure. I think we get started with a little video, so if you can cue video, please. This is always a tense moment. Nope, that's the slides.
Keep going. Yep. There we go.
1, 2. Yep.
Do we have sound?
As humans, we've always strived to create, to build something that will solve a problem or meet one of our needs.
How would you feel if you could hold some of your designs in your hand and they went like, that's impossible? And say, well, let's assume it is possible.
I'm not a designer, but now that I'm seeing the possibilities of this technology, you start to see the world differently and you start to reimagine the objects around you.
People are taking the power of creation into their own hands.
Boom. Open up your little skull, pull out your idea and create it. Like, that's what Shapeways does in a nutshell.
3D printing is a way of making things element by element additively. The things that we're designing, you can't make any other way.
I can make objects bigger, smaller, stranger. There's no limit to the variation you can apply.
I suddenly realized how much I was restrained by a lot of the technologies that were around before.
When something new comes to this home, she asks, have you bought it or have you made it?
If you look around us, we can buy any product we need to do whatever we want. What's missing, however, is our personal input into those products.
We have an idea, and then in the mail, the idea comes sort of as an object, and like, that's never existed before.
as a designer, you can concentrate on making the best object, the best product that you can, and Shapeways does the rest.
So we can make one of something and test it out. And all of this doesn't make any difference because there's no tooling, there's no molding.
There's no investment for a designer. It means also you can innovate faster. There's no penalty for innovation.
This gives rise to a whole new way of solving problems.
It's mind-blowing to think that we can build something today that was literally impossible yesterday.
So that was a bit to get started. So I founded Shapeways in March 2007, and as Jamal said, we are an online marketplace and community where people can make, buy, and sell their own stuff. And I think it's very important to understand why that is such a profound new thing. I mean, for the last 100 years, mass manufacturing has helped us get all the products we use very effectively and very efficiently. The problem with those mass manufactured things is that they are all, by necessity, the same in shape and form. And we, as humans, we like to individualize. We like to express who we are. So what Shapeways empowers is that personal input into products. You know, we, with mass manufacturing, need to have everything the same, and we don't like that. And you can see that when people customize their products. They put decals on their laptop, or they make customized cars. They make their own computers, the custom case scene. And the problem with all of that is that it's either after-the-fact customization, or it's very, very limited customization. I think the true power of 3D printing is if you make it really easy, if you make it affordable, if you make it accessible, that people can get the products they care about again. They can customize, personalize, you can get that perfect gift for that special someone, you can get that special or precise perfect product for your hobby, or to you know, put something really beautiful in your home. I think that is the power that 3D printing unleashes. And what we're doing at Shapeways is make it very easy, make it affordable, and make it fun for people to do that. And on top of that, it is a launch platform for entrepreneurs. Shapeways is now home to over 10,000 product designers, creatives, who come up with really great products, and they want to sell that to a worldwide audience. Now, in the past, if you had a product idea, it was very hard to get that product to market. You need to raise the capital to manufacture it. You need to figure out whether there was a market. You need to establish your retail channels. And all of that is now much, much easier through online platforms like Shapeways, because you just design it in 3D in your own software, you upload it to the site, and 3D printing you can predict what it will cost to manufacture. You add your own markup, and then you start selling. If you don't sell, the only thing you lose is the work you put into the design elements of it. You don't lose a big inventory that you can't sell anymore. And if you have problems with your product and your customers point it out after you sell a few, you can immediately start changing and adapting and improving the product. And you don't need to sell a rest inventory at bottom prices first. So you can see all of a sudden product designers can open a shop and can start selling to a worldwide audience, and that is happening. And the top sellers are making a lot of money already, and we intend to grow that much, much bigger. Shapeways is home to about 300,000 community members today and growing quickly. And we have over 600,000 products on the site, and also that is growing by about 60,000 products a month. And that's quite phenomenal for a company that's only 80 people. So that's Shapeways.
Great, thank you. Avi.
Outstanding. So 3D systems, can we have the slides, please? Okay. 3D Systems invented 3D printing actually outside of Los Angeles exactly 30 years ago. Can you advance, please? We, in the last 20 years, solved most of the more complex manufacturing challenges for automotive, for aerospace, for patient-specific medical devices. And in fact, everything that you use today at home, from the car that you drive to the shoes that you wear and all of your appliances and consumer electronic devices, have been designed, tested, tooled, and in some instances manufactured using 3D printing. We are a global company. We have about half of our revenue come outside of the United States. We have more patents than we have teammates in the company. And we think that this is a technology that is going to completely change how we design, what we manufacture, and how we interact with each other across many different areas, from creativity to entertainment to patient-specific healthcare to the relocalization of manufacturing as we know it, a renaissance in manufacturing, because the tooling is cheaper, the lead times are faster, the supply chain is simplified, the inventory is non-existent, and the freedom to create in an unlimited way is abundant, because complexity is completely free of charge. The printer doesn't care if it prints the most simple geometry or the most complex geometry. There is no penalty for complexity, and there is no penalty for conforming to traditional manufacturing processes. So you have complete freedom of creation. If we can go to the next slide, please. And so the question is, does it scale? And so if you look at Invisalign, the clear braces, they printed last year over 17 million, can we have the audio? Unique and distinct.
That might be the difference in 1 or 2 points of fuel burn in the way a jet engine works, and that's billions of dollars for our customers in terms of performance. Now, the way that's made today is kind of subtractive, right? You get a block of something, and you weld it, and you arc it, and you take the scrap, and it goes someplace, and that's how you make those parts today. And 3D printing allows you to make that product right the first time. It allows you to make it from the core up, so you basically don't have as much waste. The tooling's cheaper, the cycle time's faster, and that is the Holy Grail.
The Holy Grail. I was with Jeffrey Immelt at the Atlantic Conference on new manufacturing a few months ago, and that's what we talked about. We talked about a renaissance that is also sustainable, that can allow the manufacturer of very complex shapes in a new way, that could bring about significant efficiencies and scale. So if we can go to, and when you think, does it scale? As I said, Align Technologies printed over 17 million unique and distinct aligners last year in 2012 in a factory of the future that is fully mechanized, fully automated to make millions of one of a kind. So if we can go to the next slide, please. But that's only the beginning. The entire field of patient-specific medical devices, today, as we sit here, every in-the-ear hearing aid shell is printed, the finished shell. If you look at companies like Conformis to the right of your screen, every implant, not just the implant itself, but all of the surgical tools that go with it are patient-specific, are computer-planned, and 3D printed on one of our printers. And all these parts that you see there are part of a patient-specific kit that goes into the operating room. Can we go to the next one, please? And on the entertainment side, this is going to disrupt and reinvent retail as we know it, both online and in-store, because as Peter said, there is an opportunity to create immersive experiences where everybody can co-create and become emotionally involved with their brands of choice or with their designer of choice, where the designer creates the templates and the consumer personalize and begins to create real emotional equity with their brands. And so you can see two things that we're doing with Disney, the D-Tech Princess, where little girls can personalize and become the princess of their choice, or the Carbon Freeze Me example as well. And this is only the tip. Next week we're launching something with Star Trek. We have all the licenses, and so that is just the beginning. One more slide, please. And it's going to me, one of the things that I'm passionate about, and this is what that printer on the side is, I'm passionate about giving kids tomorrow's competitive learning today. So when they get to the workplace, they have a chance to create sustainable competitive advantage as entrepreneurs and creators. And so, I think that 3D printing is at the heart of disrupting learning as we know it, and giving kids the opportunity in a world that is becoming increasingly more virtual, the opportunity to connect virtual with actual and begin to unleash learning and imagination, not just in STEM and STEAM skills, but in art and music and literature, because it's a canvas for self-expression. And I have to tell you, 8-year-olds get it. They don't need a great deal of instruction. One more, please, with the audio. Can we have the audio? And the video? Or at least one? Maybe not. Okay. So the last example was what we call 3D Me. It's an opportunity to basically upload 2 pictures and turn them into a personalized figurine. So the technology is moving very, very quickly between chip sensors and smart cameras, not to just uploading photographs. And for those of you who think that we're smoking something funny, it's interesting to be reminded. Sometimes it's sobering, and sometimes it's humbling to be reminded of what happened to these visionaries. What was their Kodak moment? When they ceased to exist and began to preside over their own funerals. They just didn't know it at the time, because it's important to remember that we live in exponential times. And it's not just that 3D printing is liberating, it's the convergence of 3D printing and robotics and artificial intelligence and infinite computing power in the cloud and mobility that is creating this perfect storm to localize manufacturing and personalize medical care and disrupt education. And I'm really passionate about that. So thank you.
Okay, thank you, thank you. So why is this happening now, Peter? A lot of people regard a couple of the big TED Talks in 2011 as an impetus for the interest in this, but what is happening either technologically or sociologically that is making this, or economically, that's making this jump off and be so buzzworthy?
That's a good question, and I think it's a couple of things. But of course, before it starts to become apparent to the mass that this is happening, a lot of people have been working on making that possible way before then. As Abe mentioned, 3D printing was invented 30 years ago. It has been used for the beginning, for prototyping, and then slowly but surely, some visionaries started to see that it can be used also for final products. It can also be used in medic, making implants or all kinds of exciting new things. I think if you really look at it from a technology perspective, there's a few things. 3D printing requires computer-aided design, and not so long ago, computer-aided design tools were very expensive, only accessible to big companies that had the money to pay $10,000 and more for those kind of tools. In 2000, I was part of the first free 3D software tool, still exists, called Blender. And with that came a new wave of free 3D software that made 3D software and CAD software available to anyone, to kids, to students, to creatives. Now we have SketchUp that was part of Google for a long time. Even Autodesk is publishing 123D app, which is free. So the free software plays into this, and the computers that can support that kind of software. Then storage. I mean, the amount of data involved with those designs is large. And up until recently, handling those kind of large data sets would have been prohibitive. If all of those Invisalign dental applications were stored on a computer, if you look at it, it's a lot of data. We have 600,000 designs in our database. That's a lot of data, which until recently would have been very, very expensive to store. So, and I'm going to the next thing, which I already mentioned, hidden in there, it's price. I mean, I think with the scaling up of this technology, all of a sudden price is becoming at such a point that it becomes relevant for people to make stuff. If you can make an iPhone case for 20, 30 or 40 bucks, then people care about it. If you have to pay 300 or 400 bucks, then it's, of course, it's not really relevant. It's interesting you can do it, but you wouldn't use it for yourself. So I think it's the advances in computer technology. The internet is helping to democratize the access to this, and then it's also the price point. And if you take those together, then you start seeing why it's becoming relevant today.
So Peter mentioned price point. What is, I know people who are ordering 3D printers, obviously there are varying levels of machinery. What does a 3D printer run you?
Okay, so you can start with the one that we have with us here in the room to my left, or to Peter's left, the Cube. And that's a plug-and-play for living room and classroom 3D printer that is lightweight and portable. That's about $1,300 in the box today. And a year from now, it will be $799, and probably in the next 18 or 24 months, it will be $399 or $499. And that's how passionately we are democratizing access. But that's not enough, Jamal. I mean, we need to also democratize in terms of simplicity. And Peter touched a little bit on the software. The reality is that all of the content creation software that's out there today is still too complex. Mm-hmm. And what we need to do, and what we're doing at 3D Systems, is we're systematically dismantling the expert user friction that stands between this incredible technology and the rest of the world. And that means gamification. So we just opened a video gaming development studio in San Francisco where we're actually applying gamification technology to content creation and making simple apps. And it includes beginning to provide coloring book simplicity to the content creation from, I'm serious, from using Kinect Xbox sensors with new software that allows you to digitize in 18 seconds, from photogrammetry that allows you to upload and begin to digitize, from sketching and using tablets, and even, believe it or not, from gesturing by beginning to harness devices like the new lip motion device, which is another disruptive technology, and reshaping and redefining interactions, because that's the only way to get a liftoff here.
And so, Peter, when your company actually helps people come up with their designs and then see them come to life, can you talk a little bit about the process for an individual who interacts with Shapeways and how they come up with their design that ends up on your table?
Yep. So what you can do when you visit our site, there is actually 3 levels of engagement, if you like. First and foremost, there is an enormous catalog of unique products that designers have created that are for sale. You can pick and choose. If you find something that is to your liking, you simply buy, and then you get it, and we have beautiful designs from Nervous Systems, who are a Boston-based company, from Bathsheba Grossman, who've been pioneering the space for over a decade. So that's typically how we see people engage for the first. Then the second is that we provide tools where people can customize, where you can customize existing designs. You can put your initials on cufflinks, and then we print them in either stainless or in silver. You can use text to make napkin rings or light shades. And there is a whole slew of, you can make your own coffee cups, your own vases in ceramic. There's a whole slew of products that are easily to customize, making it so simple that everybody can engage and make things they really care about. And then last, if that's not even enough, we are compatible with all 3D software that is out there, from the high-end, like Rivet, to the low-end, like Tinkercad or SketchUp, and anything in between, SolidWorks, Rhinoceros. So, and then with that software, you start with a blank piece of paper and you can create anything. Now, we don't see everybody go through that funnel all the way down to use 3D software, because I agree with it. 3D software is really hard to use. So to make that easier and easier, I think specific, targeted apps are a way to go forward where, like the cufflinks I expressed, what do you want to do? You want to put a logo on cufflinks, you want to put your initials in cufflinks, but you don't want to make them 10 times bigger because cufflinks have a certain size. So there is limited interaction with typical products. And to enable that creativity further, we've launched an API with a set of libraries where people who want to program can create experiences, and they can connect them very, very easily to Shapeways, where we take care of the production, the customer support, the payment, all that. And you as an end user benefit because now all of a sudden it's even easier to customize specific products, and then you can get exactly what you want.
So we've seen the incredible shrinking labor force as manufacturing has become more automated. Tell us about how, on your end in the company, what happens from a workforce perspective. How many people do you have working there? How many machines does it take to make how many products a year?
Yep, so we have 2 factories now. We have a factory in Eindhoven, the Netherlands, in Europe, where we have about 9 machines that make about 400 to 500,000 products on a yearly basis. We have opened a factory in New York City, bringing manufacturing back to New York, which is 25,000 square feet, where we will have between 30 and 50 machines. And that will be able to print somewhere between 2 and 3 million products on a yearly basis, operated with 50 3D printing engineers. But I think if we only look at the workforce within Shapeways or within 3D printing companies itself as a understanding how does this bring back manufacturing jobs, I think we're limiting ourselves in our view. We'll have multiple factories throughout the country because making parts close to the end user makes a ton of sense. It's quicker to ship, it's cheaper to ship, and it has less impact on the environment. But actually, those factories have a much wider impact on their environment. Why are so many new creative products coming out of China? Because people have access to manufacturing and they can talk with manufacturers how to make stuff. Because when you make things, you always have to understand what are the limits of the technology and how can you solve certain specific problems to those products. When manufacturing is outside of the country, that kind of interaction is very, very cumbersome. When the manufacturing is close to you, you can go visit. And that's why our factories are open for tours. And actually we're going to work and make that even more of an immersive experience where creatives, entrepreneurs, or people who want to make cool stuff can come and talk to the 3D printing engineers and understand how they can push the limits. And when I spoke about the shops that we have 10,000 shops. They're all entrepreneurs. They're all people making money because of this. And we see a very rapid growth. We see today more than 200 new shops opened weekly on Shapeways. And those are 200 entrepreneurs who just started their own little business. And the successful ones like Nervous Systems or Bathsheba Grossman, as I just mentioned, they're growing businesses of themselves, attracting and creating new jobs. And I think that is a very powerful thing to understand. Having access to manufacturing gives creatives the ability to solve problems in innovative ways. And that creates jobs by itself and an ecosystem.
And right now we're seeing most of these products are, or actually all of them, are single material developed products. What's the future of this? Nanotechnology, what's happening? Having a couple different materials, metals and plastics together?
It's an excellent question. Inherent in 3D printing is that you can, in essence, manufacture a fully assembled part. So when you look at the belt that I have here, this is how it comes out of the printer. There is no subsequent assembly. The buckle is attached and all of the movement is in it. And when you look at my iPad cover, the stand came with the hinge and it was printed all in one part. And so what's the next big thing? The next big thing is multi-materials. The next big thing is functional materials. The next big thing is integrated control circuitry and motion, and that is actually in the very near term. So expect in the coming months and in the next few years to see fully integrated functionality in materials. For example, we just built in connection with the Air Force a small-scale airplane that had smart wings. And those smart wings were actuated without any hydraulics, without any flaps. It was basically morphing motion and intelligence that was built into the material. What does that do to the whole job discussion that you mentioned previously? It's really creating a different class of jobs. It's creating an ecosystem, as Peter mentioned, that has tremendous ramification as a platform for entrepreneurs to access. You know, you can do it at home. You can do it by accessing cloud printing. And for the first time in recorded human history, garage entrepreneurs have the same access to powerful technologies that traditionally were only reserved for deep-pocketed corporations. You know, that means a lot more advancement, a lot more disruption, and it also puts tremendous pressure on large companies to be at the bleeding edge of this, because if they're not at the bleeding edge, they're going to be bled by all these garage entrepreneurs. So I think net-net, it creates a lot of opportunity for big companies and startups and entrepreneurs. It's a tremendous consumer opportunity, and I think it's also very important that kids get exposed to it at a very early age, because they're going to be the ones that will take full advantage of this disruptive technology in ways that we haven't even begun to imagine.
Yeah, there's an MIT professor named Blair Evans who is in Detroit right now building fab labs in the city to be able to bring students to be engaged in creating their own products, selling their own products, entrepreneurism. I imagine we're going to see a lot more efforts like that, locating in places that are probably pretty depressed economically with these new technologies.
Absolutely, and I personally, I mean, together with 3D Systems and as a person, as a volunteer, we have done a great deal in the last 2 years to team up with the Alliance for Young Writers and Artists, which is the Scholastics Foundation, celebrating their 90th anniversary this year. And we created a whole new category called Future New, to begin to expose people that are not from engineering and robotics to the magic of using 3D printing as a canvas for creativity and communications. We just incubated what's called CityX, which is a Singularity University startup. I'm also on the faculty of Singularity, so I'm passionate about that. But we've incubated them inside our SF Creative Center because we want to develop curriculum for young kids to begin to harness this to expand their thinking and unleash their creativity. And we're doing lots of projects in inner cities to make sure that young kids begin to avail themselves to this incredible creative tool, because I believe that everybody is creative, everybody is innovative, and everybody can create. And the moment that we democratize the creativity tool, I think amazing things happen, right? I mean, look what happened to publishing with Twitter and Facebook, and, you know, for hundreds of years, publishers owned all the power. The moment that you democratize the tool, everybody can be a publisher. And that's what we're talking about here.
Great. Do we have any questions from the audience? I see one here.
I think all this is very impressive, and to be very honest, I really understand the business model for like Invisalign. That's very clear. I think.
Yeah, we've got a microphone. Hold on 1 second.
I think it's really like amazing that you can make these things yourself. But I find that when you go from the Invisalign in 17 million unique forms to what we see on the table, there's a big gap, and I'm wondering, like, where is the killer app that's really gonna, or product that's really gonna like bring this more into the like mainstream? And I'm also wondering, from an investment standpoint, how does one invest in this movement, which seems to be really gathering momentum?
Okay, so let me, you know, we're publicly traded, so I'll talk to you in terms of what has been published. So we finished last year with about 354 million in revenue. And that represented something like over 50%, I think, growth year over year. Some of it was organic, some of it was acquisitive. And most of it came from industrial applications. So from thousands of companies that are using this technology to advance their design and manufacturing operations in a big way and in a meaningful way. And that is likely to continue because the opportunity not just to mass customize, but to manufacture complex parts like Emil talked about is now well understood and accelerated in terms of its adoption. We also invested heavily in this consumer opportunity because we think that the killer app here is not in a product. The killer app is in creating a hosting, publishing, and production platform that allows individuals like Peter is doing, but also major companies like Fox and CBS and Nickelodeon and Disney and others to begin to take millions of their precious content and begin to deliver it in a way that reinvents the consumer experience and allows millions or billions of people to co-create with their brands. You know, I think that inherent in the human condition is the fundamental desire to differentiate in every way that we can. And for the first time, we're unlocking it. So if I were you, I wouldn't look for a killer app in a product. I would look for a killer app in a platform, in an ecosystem. We're building what's called Cubify.com, which is the mashup for us between an iTunes and an app store for all things 3D, with all of the gamification and apps, and where you can buy a printer or upload and cloud print. Peter is building Shapeways and leading the way in terms of a community and an exchange and stores and all the things that he eloquently talked about. And those are just two examples. As we sit here today, there are hundreds and thousands of young men and women and older men and women that are developing apps and creating contents and are doing things that you couldn't even imagine because this technology is sure to relocalize manufacturing in a big way. That train left the station, but it's also going to reinvent consumerism as we know it.
And so just real follow-up on this, quality and consistency, are you able to see the same quality out of products built by two separate
yes.
Printers?
Yeah, so good question. I think one of the tough things to do is when everything is different, and sometimes it's the same, to guarantee quality across those products, even if, for instance, one product is made in a factory which is in Europe and the other product is made in a factory in the United States. However, we found that in our passion to make this technology accessible and to make sure that everybody can make whatever they want, the best way to do that is to focus on that quality. I mean, what we're doing is we're applying lean manufacturing processes that made, for instance, Toyota so very successful. We use those technologies and we apply them in 3D printing. And what that says, basically, the short version is focus on quality, focus on quality. Because if you have very high quality and you have very little disturbances, then your costs come down, your lead time is reduced, and customer happiness in general is increased. So that's definitely, I mean, if you order an iPhone case, you want to make sure it fits, right? And it shouldn't be slightly smaller and bigger. And to come to the point of the killer app, I fully agree, it's the platform. You know, Chris Anderson, former editor-in-chief of Wired magazine, wrote a great book called The Long Tail, in which he describes that our whole thinking about hits and killer apps is driven by mass manufacturing. You need those hits, you need marketing to tell you where those hits are. Where is the next product you can sell millions of? Because mass manufacturing is only capable of doing that. However, if you start to look at industries where that is starting to go away, think about music. For a long time, the record industry owned music, but now through online platforms, musicians can start to self-publicize. It's not full mainstream yet, but you start to see, and also with journalism, like blogging and tweeting, you know, those things start to become less controlled by a few and more accessible to the many. And the same is starting to happen with products as well.
I'll defer to the history-making astronaut, Mae Jemison.
So I'm actually working on a project right now that's very much like the Star Trek that you talked about.
Okay.
It's called 100-Year Starship, and it's about how to get the capabilities to send humans to another star system within the next 100 years. And it's serious. It's with DARPA funding, seed funding. But what I'm interested in is the aspect of sustainability that's associated with this, as well as the ability to use in situ materials, or materials that you find wherever you are.
Yes.
So I see this, and I'm not looking for the killer app or anything, I see this as like fundamentally we're just at the beginning of this.
Oh, yeah.
What are some of the issues that are associated with trying to use other materials? Because right now it's being fed as a liquid, right? What are some of the issues associated with using other materials, and where do you think we are on that?
Okay, it's important to note, and you know, we can spend days educating ourselves on it, that just within 3D systems we have 7 unique and distinct print engines that can print from liquids, from powders, from solid filament, from UV curable materials, from composites, from rubber-like materials, from waxes, and from fully dense metals. And within those 7 platforms, we have more than 100 materials today that basically cover the gamut, you know, from biocompatible materials to rubber-like materials to real wax that goes into the lost wax, you know, investment casting for precision castings, to fully dense metal alloys, etc., etc. And that's just the tip of the spear here, because as Jamal already hinted, you know, we're getting into multi-materials and intelligent materials and composites. So expect to see a great deal of proliferation in materials that will over time pretty much mimic every known engineered material that you know, and completely new material discoveries that will create new sets of chemical systems and composites that will begin to integrate even smart materials in a 4D sense that begin to construct and deconstruct themselves. There's a fair bit of research ongoing now at Cornell and MIT and a few other fine research institutions that has begun to look actually at 4D materials that will have the protein chain-like intelligence to form and deconstruct and form other shapes. And all of that research is happening. In terms of space, there is a great deal of work that's being done right now with some interesting startups like Made in Space, which is another one of our Singularity startup companies. I'm plugging Singularity because I'm passionate about it. I teach there. And the idea there is to begin to have autonomous manufacturing capabilities in a box that is space-worthy. And that is happening as well.
Yes, you're on the end. Mr. Raven.
Hi. In a world where every product is unique, what emerging issues, if any, are on the horizon for product defect, product recall, product liability, and warranty? Are there any issues there?
There could be quite a few issues related to quality, except one would assume that if you made a mistake and you say, oops, I made a mistake, you made a mistake of one, not a mistake of millions, and you will have an entire community and a platform to ask for help, which is very powerful, by the way. When I don't know how to do something today, I know where to hang out online to ask for help. And I get 1,000 people that want to help me overnight. and that's how it works. You know, that's the power of crowdsourcing, you know, from people that are really passionate about this, that they will give you the answers that I could not come up with in 10 years. And I can get it overnight. It raises other issues of, you know, what happens to counterfeiting, what happens to patent infringement, what happens to illegal possession of things like guns, you know, which you may want to. So it raises. Look, this disruptive technology, overlaid on all the other exponential technologies that I mentioned earlier, are going to stress our legal infrastructure, our social infrastructures in some obvious and unobvious ways, and there'll be lots of unintended circumstances that we're going to have to wrestle with and see if our social infrastructure and legal infrastructure can actually keep pace with exponential times.
Are you dealing with product liability and any of those questions?
Yeah, we've been printing for almost 5 years now for a community that does anything and everything with their parts that they want. Although we advise them to only use it for, you know, non-directly applicable applications. You know, like jewelry is fine, things for your house are fine, but you know, you shouldn't use 3D printed parts from us directly into, for instance, load-bearing parts of your car or parts of your airplane, right? At the same time, I think we need to consider and understand that when we are moving the access of manufacturing away from big corporates to the individual, that gives freedom but also responsibility. We laugh when we say, hey, don't make load-bearing parts for your car. But we today live in a society that if you would get into an accident, then the manufacturer is liable for it. And we should maybe think about whether that is always the best way to handle those kind of problems. Because in the end, if you use a CNC machine in your home, which is accessible for much longer than 3D printing, or if you use your own hands to create something on your car and it breaks, who are you going to sue besides yourself, right? I mean, there is no liability there. So it's a very interesting topic, and I'm sure that as this industry grows, it will have those kind of questions that we need to answer in a smart way.
So
however, yeah.
All the lawyers should get ready.
Yeah.
Yep.
It's going to be
a question right here.
bonanza for the lawyers, yeah.
So Peter, whose printers do you use?
We use a wide variety of printers. We use 3D Systems printers. We use printers from EOS, which is a German company, from Stratasys Objet. We use printers from X1 and others. So because our community asks for different types of materials, we try to get the materials they want, hence the machines we need to use for that.
What's the largest scale?
The largest part is currently possible in nylon plastic, which is the size of a small fridge. So that's quite large.
Yeah, I would add to this. The largest part that we can, the largest volume that we can print at 3D Systems is 1.5 meters by 3/4 of a meter by 3/4. That translates to being able to do something like a complete car dashboard in a single piece.
So do you see this then as Kinko's of the future as you roll this out across the U.S.?
Who knows?
That's only one interpretation. Yeah.
Did I see another question over there? No? Okay, let's go to the gentleman here and then the gentleman up front.
I own a MakerBot, and while it's pretty simple to use, it actually requires a lot of attention. So I was wondering, to what extent do both you gentlemen think there'll be a printer in everyone's home in the future, and what that, you know, is going to mean?
You know, we were the unlikely company to disrupt at the low end because our DNA was professional and production grade. We deliberately entered into, if you will, you know, the entry-level space with the Cube, and the fundamental premise was we were going to Apple-esque the experience, because what's important to us is it has to be plug and play. It has to be simple and intuitive. It has to be enormously reliable. And the user experience has to be exactly the opposite of what you experienced. It has to be, you know, what can the printer do for me, as opposed to let me tinker and figure out how to make my printer work. The MakerBot by name and by DNA started for makers. So, you know, I think makers have a higher degree of tolerance, you know, for that kind of experience. Our audience is, you know, we want to have an amazing UX. We want to unleash, you know, kids in the ages of 8 to 80. We want to unleash their creativity. The moment that they begin to have some teething problems, it all fizzles away. So if you look at the Cube that we have here today, we fired it up, you know, at the speaker's lounge in less than 5 minutes, and it's been printing ever since. And not only that, it's battery operated. So when we think, you know, plug and play, that's our idea, and that's only the beginning. It's got to be about what it can do for you, not how you make it work.
Great. I think you had a question here.
Yeah. Excuse me. You said you have about 9 cubic feet that you have right now. Can it get larger? Do you have someone who's working on that?
Yes, you can increase the size of. I mean, look, Moore's law is gonna apply here every day and in every way. So expect speeds to continue to double, expect costs to go down, expect material numbers, to increase exponentially, and expect printers that will print complete homes, which is, by the way, a project that many companies are working on. So size is not gonna be a factor as much. And expect printers to print food and to print organs and to print other body replacement parts like bone structures and to print chocolate and everything in between. All of that activity is happening as we speak. It's not some kind of a futuristic sci-fi video clip. It's happening right now.
And what's your market share between the two companies?
Yeah, and I want to hear a little bit about your size question, to answer the size question from your perspective.
Sure. So yeah, I mean, the size question I answered, the bigger things get, at some point, shipping becomes a bit of an issue. Then you have to start thinking about local manufacturing in the truest sense of the word. If you think about consumer products that we are currently printing, they are small today because the price is directly dictated by the size of the item. It comes from the time the machine takes to make it and the material you use. And therefore, currently, people decide to make smaller things because they decide with their wallet. If you make a vase that is the size I have here, it's about $100. If you make it for the eye twice as big, you use actually 8 times the amount of material and machine time, and it becomes $800. And that's currently what is limiting size. We're working tirelessly at Shapeways to make it accessible, driving down price, so it will happen over time. I do agree that in different ways or forms, making homes gives very interesting possibilities if you print them. We can talk about that for an hour. You don't need air conditioning anymore, for one.
And what was your follow-up?
Just the market share between the two companies.
There is no, I mean, to begin with, most of what we do is complementary. It's not competitive, and actually we supply Peter in part, and we also compete with him a little bit. But there is no meaningful market share today. We have a very different business model. We intersect with Peter in one area, which is the platform for consumers. That's where we intersect. Most of what we do today is aimed at disrupting manufacturing in a big way, and education and healthcare. And generally speaking, although we generated $354 million in revenue last year, we think that it's insignificant because in the real sense, our competition is traditional ways of doing it. And in that regard, we're not even beginning to move the needle.
Yeah,
one more question here, and then I think we're closing in on the end here.
Today you've spoken a lot about all the production has been at your facilities with your printers on a factory site and then shipped to the end user. You also have, you're demonstrating the home model. So I was just wondering, which way do you think the business is going to go, or do you think it'll be a combination of where you are delivering the finished goods versus people will have the technology in their homes, and that the dealers will essentially be dealing in data sets where we would ship you the plans, and then you would hit the button on your printer and it would more replicator like.
Well, I'm grateful that you asked this question, because it means we failed to communicate. 38% of our revenue last year came from selling printers to companies and individuals. Another 30% came from selling those same companies and individuals the materials that they needed, and the remainder came from on-demand print services. We have 9 manufacturing facilities around the world that do professional print services on demand for all these customers. And so our leading revenue source is actually making and selling. We have 40 different 3D printers, starting from $1,300 all the way to $1 million and everything in between, in the 7 engines that I discussed with more than 100 materials. That's where we see that ultimately there will be a printer in every home, and ultimately there will be the Kinko's of 3D printing and community, and there will be factories, you know, like Peter's and ours that will do cloud printing for all the other sizes and all the other materials and all the other processes that may not be effective to do directly at home or in your neighborhood or community center. But there is no question that we'll be dealing in data sets. There's no question that we're going to disrupt the traditional supply chain. There's no question that it's going to distress existing models like FedEx and UPS and others. It's inevitable. It's the only question is, are they going to be part of the revolution, or will they have to react to it?
What do you think about the
So I
democratizing of the printer?
So I think it's an interesting question. I get asked that a lot because we don't have a 3D printer that we sell. We provide service. And just like, I think a nice analog we can make is if we look at the paper printer that a lot of people have at home, but also the services that exist around it. Kinko's has been mentioned and others. I think over time more and more people will have a 3D printer at home because you know, it gives you local access. You can see how it works, but also you can create stuff almost instantaneously. You have to wait hours instead of maybe a day or days if you order it online. However, what is interesting to me to observe is what are people making. And you know, I have a printer at home that can print in paper. I can print beautiful color photographs that I take. But if I look at the behavior of my wife, who is less of a technology adept than I am, she uses a service to print photos because she wants to make a book. And I think that we need to realize that the printers, however cool and advanced they are today, are a tool in manufacturing. Manufacturing always composes of more steps. You have to analyze whether it can be printed, you have to print it, and then sometimes, and most often actually, you have post-processing steps. You have to polish it, you want to maybe dye it or color it, you may need to assemble it. And if you think about that photo book, and I'm sure quite a few of you have tried to have used those services where you upload pictures and make your own, you know, book with your holiday pictures or whatever, or wedding pictures. If you think about it, that's the same thing. You upload the pictures, you could print the pictures at home, but making the book is much more elaborate. Could we do that at home? Probably yes. But it's a lot of work that we don't bother, and we are afraid that we won't achieve the same quality. So digging in some more, I found that actually today still 98% of paper printing happens in the cloud and only 2% happens at home. So yes, I think that having a printer at home is useful, just like having a paper printer. So you can see what it looks like, you can do some actually prototypes. And then the high-end machines and the services that are associated with that will be very appealing still, even in today's market where everybody has a home printer. You see so much printing going on still in the cloud.
So I'm going to take a point of personal privilege at the end. Our firm help manages Mayor Bloomberg's Mayors Against Illegal Guns effort. What is the deal with the 3D printed gun that is all in the news?
Okay, so as you know, Defense Distributed, Cody Wilson demonstrator, who is a law student, by the way, yeah. Is pushing the envelope on what can be done with a 3D printer, and he basically printed the lower case of an AR-15, in essence demonstrating that you can convert, you know, into a fully automated weapon that's illegal, and he did it in a material that's undetectable. The deal here, in my mind, is that, not that he did it. I mean, the reality is people could have done it 10 and 15 years ago. If they're good machinists, you don't need a printer. The big deal is that now you don't have to be a good machinist, because with 3D printing, craftsmanship is democratized. And when craftsmanship is democratized, you know, now you put that power in the hands of anybody who can access the file and print it at home or upload it to a service and have it printed. So it begins to test the boundaries of what we have to do in terms of a responsible society. Is this something that we need to deal with? Absolutely. Is this something that we as makers of 3D printers can effectively deal with? Not in the sense that we're not a law enforcement agency and we're not a legislative body, but I feel that we have a responsibility to talk about it, to educate, to sensitize, to collaborate, to advise. And there are certainly some technology-centric solutions that could be applied here to make it harder. The risk is that with everything that we see come out of the legislative bodies, there could be an overreaction. The pendulum can swing to the other extreme from the Wild West, to highly controlled. And with that, it could have other unintended consequences of stifling creativity and stifling democratization of what's good. And that's a debate that I assume you guys will be busy advising and being in the middle of for quite some time.
I'm sure. That brings us to the end of our session. Thank you all for being here, and thank you to our panel.
Thank you.